Hello everyone. After releasing the video of quantitative analyses on motorcycle low-frequency rumbling noise, we have received many compliments and at the same time inquiry on how SoundViewer works and its comparison to beamforming technology. Detailed explanations can be made in another video. Here we will just give short answers to these questions. SoundViewer is built on the principles of passive SODAR and the Hells method, both of which are our proprietary and patented technologies. SODAR stands for sonic detection and ranging. You can think of SODAR as radar, except it is passive and uses sound waves rather than radio waves. It enables one to pinpoint the locations of multiple sound sources simultaneously, even when the signal-to-noise ratio is negative. Hells stands for the Helmholtz equation least squares. It is a very powerful tool to reconstruct all acoustics quantities generated by a sound source. For the second question, we will display comparisons of the functionalities of SoundViewer and beamforming. As you can see, both of them are non-invasive, easy to use, and suitable for transient and flow-induced noise sources. Other than that, there's no comparison between the two. Basically, SoundViewer provides a comprehensive and quantitative analysis, whereas beamforming offers limited and qualitative information of a sound source. Specifically, SoundViewer is capable of analyzing sound sources over frequencies ranging from 20 to 20,000 Hz with very high spatial resolution and very large dynamic range, providing source depth information, reconstructing all acoustics quantities such as the acoustic pressure, acoustic intensity, acoustic power, and acoustic radiation patterns on source surfaces to provide a 3D global view of sound sources and their fields. In addition, SoundViewer can perform CAT scans, eliminate random background noise and interference signals, and locate and extract target sound sources and their acoustic characteristics at negative signal-to-noise ratio as low as -30 dB. Finally, SoundViewer can accomplish all these tasks by using 6 microphones, so its overall cost is very low. Now let's look at an example of using SoundViewer to diagnose and analyze an electric motor and gearbox noise on a factory floor. Note that the signals measured by microphones included everything such as background noise and interfering signals. Here's how it sounds. Using SoundViewer, users can obtain comprehensive and quantitative analyses of electric motor and gearbox noise. Specifically, SoundViewer enables us to examine the acoustics characteristics of any selected orders at any specific speeds, the corresponding frequencies, locations from which sound is generated, source strengths in terms of the instantaneous sound pressure level in dBA or time average sound power levels, so as to rank the relative contributions of individual noise sources. Now let us look at where sound is generated and the instantaneous SPL in dBA of the 27th and 54th gears in both 2D and 3D space, while the motor is ramping up from 100 RPM to 5,000 RPM. Note that all background noise and interfering signals are eliminated in order tracking analyses. In a similar manner, we can examine where sounds are generated and their instantaneous SPL in dBA of the 27th and 54th gears in both 2D and 3D space, while the motor is cruising down from 5,000 to 100 RPM. Thank you for your attention. For more information, please contact us at seanwu@signal-wise.com.